Okay, so what we're going to talk about today is the arithmetic sequences. So if we think back to last section, we're going to say that last section we discussed sequences in general. So if you remember, what we did is we defined, hey, this is what a sequence is, and then we kind of worked with different types of sequences, okay? So what we're going to do now is we will now focus on a specific type called an arithmetic sequence. Okay, so that's kind of going to be our main focus today. It's going to be like, hey, let's focus specifically on arithmetic sequences, and then that will that's one specific type of sequence. So we just have to be careful that we don't treat everything like an arithmetic sequence. So we will in a minute define what an arithmetic sequence is. Okay, so let's actually do that now. So to define what an arithmetic sequence is, we know that an arithmetic sequence is a sequence of the form a comma a plus d comma a plus 2d comma a plus 3d comma and so forth, okay? Where a is the first term, and d is the common difference. Okay, and if you remember last section, we were able to write formulas of sequences explicitly, and an arithmetic sequence has an explicit form. But before we do that for a minute, so let's look at what an arithmetic sequence is. If you think about it, what is it that we have? We start off with some our first term, and then what happens to the next term? We add some number to the first term, that's what we're calling our common difference, which is d. And then what happens from here to here? I add another d. What happens from here to here? I add another d. So in other words, an arithmetic sequence is a sequence where you just keep adding the same number over and over and over. Okay? So with that said, the nth term, which this is coming up with the explicit formula of an arithmetic sequence, is given by the following. A sub n equals to a. So remember, a is our first term. So remember, this is the nth term. So if I'm going to go to the nth term, to a, I need to add what? The common difference, how many times? N minus 1 times, because remember, the first term is a, so it'll be n minus 1 d. Now see, what would the first term be? The first term is a. So look, if n is 1, why do we care about this 1 minus 1? Because the first term, we shouldn't be adding d to it. So if I plug in 1 for n, this zeroes out and I have a. So if I want to get to the second term, which is a plus d, then what do I have to plug in for n? I have to plug in 2. So what do you get? Notice if I plug in 2 for n, I get a plus 2 minus 1 is just 1 times d, which is just a plus d. The third term, if I plug in 3 for n, I get a plus 2d, and so forth. So hopefully you see why this makes sense, that that's actually our explicit form. So this would give us the nth term of an arithmetic sequence. Now remember, this is only for an arithmetic sequence. Okay, so whenever we have an arithmetic sequence, we can use this. So for instance, arithmetic sequences are very, very simple to identify. So if you look at this, we have 1, 3, 5, 7. This is in fact arithmetic. Oh, sorry. This is in fact arithmetic. How come? Because notice how I'm going from one term to the next. I keep adding the same number. And by the way, you could also be subtracting the same number, right? So just d would be a negative number. But from one term to the next, what do you notice? What's my common difference? It's 2. Every time that I go along to the next term, it's 2. Therefore, this is arithmetic. So we would say that this is arithmetic with, what would our common difference be? D is 2. Okay? So that's kind of what we want to look for whenever we're dealing with arithmetic sequences. Okay? So with that said, let's look at our first example. So for example 1, this is saying find the nth term of the arithmetic sequence, which is 9, 4, -1, -6, -11. Okay, so when we're being asked to find the nth term, once again, what is it that we care for? We care to find the explicit formula. So we're told that this is arithmetic, but even if we weren't, we could probably, by looking at this, we'd notice that, hey, this is in fact arithmetic. How come? Because every time I move to the next number, what are we doing? We're subtracting 5 from this. So it is in fact arithmetic. So if you think about it, our formula that we just talked about is, for the nth term, is this. So what is it that I need? I need the first term, which notice how I already have, and I need the common difference. And we just figured out what the common difference was. What happens, what am I adding every time? I'm adding a -5. So what is it that we know? If you notice that every time we're adding a -5, D would be -5. And once you have the first term and the common difference, then we could easily write this equation. So the equation that we want is a sub n is equal to 9 plus n minus 1 times -5. And if we want to simplify this to kind of clean it up, we could do that. That's not a problem, because if I distribute the -5, what do I get? -5 times -1 is 5. If I add it to the 9 is 14, and then I get minus 5n. And so there you have it. There's our arithmetic, the nth term of this arithmetic sequence. Okay, so let's move on to example 2. So for example 2, we have the following. So find the common difference, the first 6 terms the nth term and the 100th term of 5, 12, 19, 26, and so forth. Now, we can pretty much guess that this is in fact arithmetic because they're asking for the common difference. See, only an arithmetic sequence has a common difference. But even if we weren't sure, just by observing here, what is it that you notice? Every time I move along, I'm adding the same number. And in this case, what is it? I'm adding 7. So to answer the common difference, we know that D is 7. Now, stating the first 6 terms, that's not difficult because what do I know? I just keep following the pattern. So if you think about it, the first 4 terms have been given to us, and all we need to do is find the next 2 terms, which, how do we find the next 2 terms? All we need to do is keep adding 7, right? Because that's the whole pattern of an arithmetic sequence. So if I add 7, I get 33 and 40, okay? So, and there you have it. So that answers this part. And then what are they saying? Find the nth term. So the nth term is not difficult. We have the explicit formula. And what is it that we need? We need the first term, which we have, and the common difference. So the nth term will be just 5 plus n minus 1 times 7. And if we want to clean it up just to make it look good, what is it that we get? 7 times -1 is -7, plus 5 is -2, plus 7n. Okay, so that's what we have. Now to finish this off, by finding the 100th term, well, I could just use the explicit formula and plug in 100 for n. So if I plug in 100 for n, which would be the 100th term, I get -2 plus 7 times 100. So 7 times 100 is 700, minus 2 is 698. Okay, so we just answered all the questions. Now remember, one other comment that I forgot to make earlier, since the arithmetic sequence is a sequence, remember its domain is what? all the natural numbers. So how do we find 5? By plugging in 1 into the domain. So notice if I plug in 1 for n, I get -2 plus 7, which is 5. Okay, so just keep that in mind. Let's move on to example 3 before we talk about these partial sums, and then that should pretty much wrap up this section, right? So this arithmetic sequence stuff, hopefully you're not finding it to be too difficult, because to be honest with you, of all the sequences, it's the one that's most straightforward. So now let's kind of go on and change this question up a little bit. So the 11th term of an arithmetic sequence is 63, and the 15th term is 87. Find the 800th term. Okay, so for this one, to answer this question, see, I would rather, see, instead of finding the 800th term, like a lot of people will make a list and go to the 800th term. That's way too excessive, right? So I personally would rather find the explicit formula, and then I could plug in 800 for n to find the 800th term. So in other words, here's what I want. I want a sub n is equal to a plus n minus 1 times d. Except what is it that I need? I need the common difference, and I need the first term. Now, unfortunately, the information provided here doesn't give me the common difference and the first term. So I have to go about using this formula to help me force out the first term and the common difference. And how do we do that? Well, look at the information that's been given to us. What's the first information? What are they telling us? The 11th term is 63. So in other words, if I replace n with 11, this whole output should be 63. So in other words, a sub 11 equals to 63. That's what this means for that guy. Now, what's the second piece of information? The 15th term is 87. So in other words, we also know that if I plug in 15 for n, I should get 87 as the output. So here's what I'm going to do. I'm going to first plug in 11 for n, and then this is going to become 63. So in other words, here's what we're saying. A sub 11 is equal to what? A plus 11 minus 1 times d. Okay, so I could actually simplify this further. Now, what is it that we know? A sub 11 is equal to 63, so I could replace 63 in place of a sub 11. So this becomes 63 equals to a plus 10d. Now, if you look at this, what's the problem? I have one equation, two unknowns. So hopefully some bells are ringing in your head. You're probably thinking, hey, wait a minute, if I could come up with a second equation, I could solve this using the system of equations like we talked about last chapter. And that's exactly what we're going to do, because where am I going to get my second equation from? It's this guy. Okay, so what else do we know? A sub 15. Now, what am I doing here? I'm plugging 15 for n, and this becomes a plus 15 minus 1 times d. Now, what do I know? I could replace a sub 15 with 87. So this becomes 87 equals to a plus 14d. Okay, now here's my system of equations, and this isn't a difficult system of equations to solve, because what is it that we could do? I could say, hey, since these are the same, take the first row and subtract the second row from it. So if I use row operations and I just subtract them, what is it that we get? What's 63 minus 87? That's going to be negative 24 equals to a minus a, that goes away. 10 minus 14d is negative 4d, and what is it that we notice here? If I solve for d, divide both sides by negative 4, d is 6. So if d is 6, and that's my common difference, I can then come up here and use any of these two equations and replace d with 6 and solve for a. So if I do that, what do I get? 63 equals to a plus 10 times 6, which means this becomes 60. If I subtract 60, I get a is equal to 3. So the hard part is done. Now comes the easy part, because what do I know? I could come now up here and say, look, we know that our explicit formula for the arithmetic sequence is going to be what? The first term, which we found is 3, plus n minus 1 times 6, which is our common difference. Now, to answer this question, what's the 800th term? That's not difficult, because now we just replace n with 800, and then we can solve this out. So we get 800 minus 1 times 6, and at this point, what is it that we get? We get 3 plus 799 times 6, and I'll go ahead and let you complete this. Let's see, actually we could probably do this. 4,800. So 799 times 6 is going to be 4794, I believe, and just verify the math because I'm just doing all this in my head, which becomes 4797. So that's what the 800th term should be. Okay, so hopefully you're pretty comfortable with the stuff we've done so far. So now let's actually talk about partial sums with arithmetic sequences. So that's going to be our focus now. So our focus is partial sums of arithmetic sequence. Now, if you remember, a partial sum from last section was what? We added the first however many terms that it was of a sequence. So we're doing the same thing here, right? Except now we're saying, look, we have an arithmetic sequence, and the good news is over here we have a formula that we can use to find these partial sums. So for the arithmetic sequence, we have these nice formulas that we could use, and there's two of them. They're equivalent. It doesn't matter which one of the two you use. So we would say for the, now remember, this only applies to arithmetic sequences, okay? So let's just be clear here. This can't be used just on any, to find the partial sums of any sequence. It has to be specifically for arithmetic, okay? So we're going to say for the arithmetic sequence, given by a sub n is equal to a plus n minus 1 times d. And of course, anytime we could write something of this form, it definitely is an arithmetic sequence. How come? Because it has a common difference, right? That's kind of what gives it away. If I have a common difference in my sequence, then this is an arithmetic sequence. So the nth partial sum. So what does that mean? If I'm adding, the nth partial sum is what? Finding the sum of the first n terms of my arithmetic sequence, which if I were to write it out, it's like this. If you remember, it's capital S sub n, right? So this is what's telling us that I'm finding the sum of the first n terms. So technically speaking, what would that be? That would be a plus d plus a plus 2d plus a plus 3d. If you think about it, we're going to keep doing this, and we're going to keep going until we get to which one? The nth term, which is a plus n minus 1 times d, right? Because that, if you remember, that's what the formula for the nth term is. So if you think about this, this is definitely an arithmetic sequence, except instead of having the commas, we have the pluses, which that's what a partial sum is. So I'm trying to add all of these, right? So instead of doing these by hand and just finding them by hand, the good news is for the arithmetic sequence, we have a formula we could use. So this is given by the following formulas. Okay, now these formulas that I'm going to give you, they're equivalent. They're the same. So you could use any one of the two whenever you're finding the partial sum, okay? Sometimes one is better than the other depending on what information is given, but I'll show you how they end up being the same thing. So the first one is S sub n is equal to n over 2 times 2a plus n minus 1 times d. So in other words, when would you use this formula? Is if you know what your first term is and what your common difference is, right? And then n is, we'll know what n is because n is how many terms it is that we're going across. Or equivalently, we can use the following. S sub n is equal to n times a plus a sub n over 2. So this one is saying instead of this, if you know the first term and the nth term, or the last term of the sequence, then you could use this formula. Now, what I'm claiming is these two are the same thing. So let me show you how they are the same thing. If I could show you how we could start with this and end up to that. So let's actually do that real quick. So if I start off with n over 2 times 2a plus n minus 1 times d, and the manipulation is very, very simple. We could rewrite this as n over 2 times a plus n minus 1 times d. Now if you look at what I did from here to here, what did I do? I just wrote the 2a as a plus a, right? And there's nothing wrong with that. We can do that. Now look, if you think about this, what's that formula? Isn't that the formula for the nth term of the arithmetic sequence? So then this, what I could do is I could replace it with a sub n, which notice how this now becomes n over 2 times a, which is right this guy because I didn't do anything to that guy, a plus, now I'm saying instead of this, replace it with a sub n. Now notice how this is literally that equation, except the only difference is the 1/2 has been put down here, which it doesn't matter. You could leave it like this or that. So we see that they are exactly the same. How come? Because I started with this and went to that. So just keep in mind, whenever you're finding partial sums, you don't have to use both formulas. Choose the one that's more convenient for you. So just keep that in mind. So you don't have to do both, just pick one, and sometimes one might be simpler than the other. So let's look at a couple more examples, and then that will wrap up this section. Okay, so now let's look at example 4, which says find the sum of the first 40 odd numbers. Okay, so over here, what is it that we're saying? Well, we first need to figure out, make sure that this is arithmetic. And in fact, it is, because if you think about it, if I were to make a short list, what is it that I know? I have 1 plus 3 plus 5 plus 7 plus 9, so on, right? And so what do I want? I want the sum of the first 40 odd numbers. But you could clearly see that this is arithmetic. How come? Because every time I move along, I'm adding 2. So we know that the common difference is 2. We know that the first term is 1. I don't know what the 40th term is. I mean, I could find it if I want, but to be honest with you, I don't care to do that, because what is it that we know? N is also 40, because we want the sum of the first 40 odd numbers. Which means I could use the first formula, which was S sub n is equal to n over 2 times 2a plus n minus 1 times d. Okay, so this one in this case becomes the more convenient one. It's not that I can't use the other one, it'll just require a little bit more work. But notice how I have the first term, I know what n is, and I know what d is. So S sub 40 will be 40 over 2 times 2 times the first term, which is 1, plus 40 minus 1 times 2, which now if I simplify this, which is going to be 20 times 40 minus 1 is 39. 39 times 2, this becomes 78. 78 plus 2 is 80. So 20 times 80 is 1600. And there you have it. So this formula, look at how it conveniently gave us the solution to the sum of the first 40 terms of this arithmetic sequence. Okay? So with that said, let's look at one more example, and then that will basically finish this up. So this is saying find the following partial sum, which is 100 plus 94 plus 88 plus 82 plus all the way to 10. Okay? So here's the problem. See, I know what the first term is. I know what the last term is. So if I want, I could use this formula, right? I could use a plus a sub n over 2. Except here's the problem. I don't know what n is. So we still need to figure out n. So how do we go about finding n? And see, the way we'd find n, we need some information, right? In fact, we have the last term. So if you think about it, how could I find n? And this is a little bit tricky. But if I go back to the explicit formula, see, here's the problem. I know the last term, or a sub n we can call it, because we can call this n unknown for now. I know the last term. So, and I know what the common difference. What is the common difference? The common difference is 6. So if you think about it, and I know what the first term is, a is 100. So if you think about it, if I plug in 10 for a sub n, and I plug in 100 for a, and I plug in 6 for d, this n that I solve for will be what? The last term, right? So this will tell me exactly how many terms I have. How come? Because this n that I'm interested in, right, this n is tied to that last term. So it's basically saying, hey, what does n need to be here for me to get 10? So it's kind of like I'm using the explicit formula and I'm working backwards to help me find n. So with that said, we know that the explicit formula is going to look like this: 100 plus n minus 1 times 6. And if I want to simplify this a little bit just to clean it up, what would that be? A sub n is equal to negative 6 plus 100 is 94 plus 6n. Okay, but what I care about is, look, when I get to my last term, what's n? What n corresponds to that last term? So how do I go about finding that? Well, I could replace a sub n with 10 equals to 94 plus 6n. So now what could I do here? I could go ahead and solve for this. Okay, so, oh, and one other comment. I made a minor mistake here. D should not be 6. D should be what? Negative 6, because every time I go along, I'm taking away 6. So this should be a minus 6, which changes this up a little bit, right? So I was making a slight error, because what do I know? Negative 6 times negative 1 is 6 plus 100. So this should be 106, and then minus 6n. So let's get rid of that. So now this changes to what? 10 equals to 106 minus 6n. Okay, so if I do this and I solve for this, what do I get? I get 6n is equal to 96. And then if I divide both sides by 6, what is it that I get? I get n is equal to, what is that? What would that be? I believe it's 18, right? 17. So let's see. It is actually 16, yeah. So n is 16, okay? So if n is 16, now I have everything I need, right? So n is 16. So in other words, I'm trying to find s sub 16. So that becomes 16 times the first term, which the first term was 100, plus the nth term, which is 10, all over 2. So what does this become? How you simplify it doesn't matter. So we have 16 times, this is what, 110 over 2 is 55. So if we say 16 times 55, what do we get? We get 88, I believe. 880 actually. So that becomes 880. Okay? So and that basically takes care of this. Now, for this partial sum, I chose to use this formula. Once again, it doesn't matter which one of the two formulas you use. They're all going to be equivalent. Okay? So you just go with what you think makes sense for you, and based on the given information, whatever you're comfortable with, work with that. So anyways, this wraps up the notes for the arithmetic sequence. And as always, if you have any questions, don't hesitate to email me.